Hello students, good day. You're welcome to basic science class. Today we'll be discussing light energy. Light energy is a form of energy which our sense of sight can dictate. That is, every one of us, we can see the lights. So that's why it's a kind of energy which our sense of sight can dictate. Now, if you're looking at light, it is made up of electromagnetic radiation. And you all know that light travels on a straight line. At least you have been hearing that the light travels on a straight line with a very high speed. That's why you see sometimes, let me take it as an example. When the light officials, when they are able to on our light, you see that before you know it, every part of your community would have dictated the presence of the light. So it travels very fast and is on a straight line. Light exhibits some characteristics, that is, it has some properties like reflection, refraction, diffraction, and it also undergoes interference. Now, if you still remember when we discussed sound energy, you see that some of this property was, we also discussed it during sound energy, which I told you then that sound undergo reflection, refraction, interference. So also light energy undergo reflection, refraction, diffraction, interference. And like I said, it can be absorbed by colored objects. Don't forget, we are talking about the properties of light. I said it can be refracted, it can be reflected, then it can be diffracted, it undergoes interference, then it can be absorbed by colored objects. Don't forget, I said it moves on a straight line with a very high speed. Now I want to be talking about the properties of light one after the other. Now, reflection. What is reflection? If you still remember, reflection is the bouncing back of sound. When during the lecture, during our sound energy class, I told you that it's a bouncing back of sound wave when it hits an obstacle. Now, in light, reflection is the bouncing back or sending back of light ray when it hits a surface. That is, when it hits a plane surface, there's going to be a bounce back. There's going to be a sending back of this light ray. Then you call it reflection. Lights, for example, light bounce off objects in our eyes to see things. We are able to see things because of reflection. Do you understand now? So your eyes see different things because the light bounce off objects in our eyes. So we can don't forget, I said is the bouncing back of light ray when it hits an obstacle. Now we have two major laws of reflection. The two laws of reflection says that the incident ray, the reflected ray, and normal at the point of incidence all lie in the same plane. The incident ray, the reflected ray, the normal at the point of incidence all lies on the same plane. Let me make this illustration. Now, this light ray, let's say you on your torch, and your torch, or as in there's this kind of blockage by the wall with the torch light. You see that there is a kind of reflection from the back, not even at the back. Just try to do it after this class, maybe in a very dark place, or let's say a cool place that there's no light, there's no ray of light. You just on your torch, allow the torch, the surface of the torch to what? As in the light, when you allow the light to reflect on a plain wall, you will see that it's as if there is a reflection of the light at the back. Let's say there's also a plane at the back. So, like I was saying, I said the two laws of reflection, the incident ray, the reflected ray, and the normal at the point of incident all lies on the same plane. When a ray of light hits a plane, then it's going to be bounced back. Now, the ray of light that hits the plane is called incident ray. The one that bounces back is called reflected ray. Now, in between the incident and the reflected ray, you have one line called called normal. In between the incident ray and the reflected ray, you have normal. So the angle between the incident ray and the normal, the perpendicular line between the incident ray and the reflected ray is called normal. Now, in between the normal, there is an angle between the normal and the incident ray. You call that angle of incidence. And in between the reflected ray and the normal, there is also an angle called angle of reflection. Now, don't forget, I said the ray of light that hits a plane is called the incident ray. The one that bounces back is called the reflected ray. And I said there is a perpendicular line in between the incident ray and the normal, incident ray and the reflected ray. This perpendicular line is called normal. Now, that is the first law of reflection. Now, the second law of reflection says that the angle of incidence is equal to the angle of reflection. Angle of incidence is equal to the angle of reflection. That is, the two angle between the two angle, that is the incident angle and the reflected angle, the two angle is the same thing. So that's why the second law says that angle of incidence and angle of reflection is equal. Now, don't forget I told you that incident ray is the ray that hits the plane. That is, the ray of light that hits the plane is called incident ray, while the ray of light that leaves the plane, that is, that bounce back, is called reflected ray. The point of incidence is the point at which the incident ray strike, while the normal is the perpendicular line at the point of incident, that is, the perpendicular line between the incident ray and the reflected ray. Now, angle of incidence, don't forget I said, is in between the incident ray and normal, while angle of reflection is in between the normal and the reflected ray. So that's that on reflection. Don't forget I told you that reflection is the sending back of the light ray, of the ray of light, when it hits a plane. Now quickly we'll move to refraction. Now, refraction is the bending of light ray as it crosses the boundary between two media of different density. So let's take an example. You see that when a ray of light that is coming from air enters water, you know, the air and water are of different density, that is, they have different density. Now, if the ray of light that is coming from the air enters into the water, there's going to be a bend in the ray of light, because the density of water is different from the density of water is different from the density of air. So therefore, there's going to be a bend as it's coming from air into the water. There's going to be a bend in the ray of light. Light changes its direction as it travels from air to water. So that is just it. The reason is just because there is differences between the density, that is, the density of water is different from the density of in the air. Now, if you look at it, you will see that where you get that better is that when you put your pencil or maybe spoon inside a glass of water, you see that when you view it, it will be as if that pencil or that spoon is not straight, and it will be as if it's closer to you, even more than the distance which the cup I mean the depth of the cup. The reason is because refraction has taken place. So that will take us to real depth and apparent depth. Now, like I said, when you place your spoon inside the cup and you want to view it, you will see that one, the spoon will be as in it will look as if the spoon is bent. Then another thing is that what you will see again is as if the spoon is closer to you. Even when you look at the depth of that cup, you are looking at it as if it's closer to you. So real depth is the actual distance of an object from the surface of the water. So the real depth, that is the normal depth of that spoon, is the original depth of the cup. While the apparent depth is the depth that is seen after refraction has taken place. So immediately when refraction has taken place, you will not be seeing that spoon in that, as in the distance you will be looking at. It will be as if the spoon is closer to you, whereas it is not. It's far away from you. That is why you see that if you have ever been to swimming pool before, you will see that when you get to the edge of the swimming pool, it will be as if the pool is not it doesn't have depth, whereas that is not the normal depth of the pool. It's because refraction has taken place. So you are not. So if an amateur is just looking at it, this pool is not. I can still swim. Such a person will endanger his or her life, because you are seeing it. It will be as if it appears to be shallow than it really is. So that's it. It is because refraction has taken place. So as soon as refraction takes place, you will not see the depth of water. You will not see the actual depth. What you'll be seeing is the apparent depth. That is the depth that you are seeing after refraction has taken place. Now, fish appears to be nearer to the water surface because refraction has taken place. If you are looking at fish as well inside water, it will seem as if you are looking at it very close to you. But that is not the depth at which the fish is. The depth of that water, the fish might even be down the water, but because refraction has taken place, you'll be seeing it as if the fish is closer to you. So that's refraction. And that was why I said it in the beginning, that when refraction has taken place, one, you'll be looking at it as if the object you are viewing is bent, because the density of the air through which you are viewing is different from the density of water. So by next class, we will be discussing refractive index. We'll continue with refractive index, then dispersion of light. So I think with the little explanation, you are able to understand light energy to some extent. Till next class, stay blessed.